Hello students, good evening and welcome to APJ Academy. So hope you all are doing good. See students, as you have seen in the thumbnail, today we are going to start a new chapter, and the name of the chapter is States of Matter, and you know that. And today we are going to discuss about the gas laws, which is a simple concept and also an important concept. Okay, so I again welcome you all to APJ Academy. Let me check with the YouTube so that I can see your comments. Okay. Yeah. Right. So this year's NEET exams have been completed. You all know that. And being a chemistry teacher, I would like to give a brief talk on how chemistry was. Actually, the paper was, I would say that it was an average paper. It was not easy as of in the previous year, but a bit average paper it was. But one thing is clear from that is, if you prepare from NCERT line by line, you study from NCERT and solve all the exercises from NCERT and practice more problems, this will surely help you score full marks from chemistry. Okay, no doubt in that. Okay, this is the strategy you have to follow for the next year's NEET exam. Again repeat, completely read line by line from NCERT textbook, solve all the problems, even the in-text problems as well as the exercise problems from each chapter from NCERT. Then practice more and more problems from any guide or whichever book you prefer. Okay, so this is the strategy, or this is the strategy which is going to help you in the upcoming exam. So students, today we are, as I've told you, we are going to discuss about the new chapter, and that is States of Matter. Yes. So before going into the chapter directly, I would like to introduce to you about our full year course. See, we provide quality content to the students along with the PDF materials. We have 25 major test series. You know that it's so important to write tests regularly, because that's the only thing which will help you to score more marks. Okay, giving test is an unavoidable practice while you are preparing for a competitive exam. Then we provide the query solving, and we also give a detailed explanation of the concept with proper conceptual clarity. We provide all the lessons, and also along with that we provide the assignments after every chapter or every lesson. We provide the assignments. Okay students. Okay, now after every session, actually, okay, this is the full year course, which is more than enough for you to crack NEET, right? So the next slide, for this all, we are only providing this whole course. We are only providing the whole course for just 490 rupees per month. Okay, that's the fee you have to pay, and it's not a, it's a very meager fee, right? It's not a big deal. So now, if you are watching this channel for the first time, I can guarantee you that this channel will surely add value to your preparation, because we are providing quality content for free. So if you are watching this channel for the first time, please subscribe to this channel, and this channel will surely help you to progress in your academics. Okay, and also one more thing, that you also have to share this channel with your friends, and relatives, those who are preparing for NEET. Please share this channel so that they can also take advantage from this channel, because we are giving it for free. So you can use this channel to understand the concepts crystal clear, and also it will surely help your preparation. Okay, and that's about me. You can read it here, who I am, what I am, right? Now coming to the topic here, students, states of matter is a chapter from the physical chemistry from +1 and from 11th standard, and you also know that it's an easy chapter, and there is a similar chapter which you study in physics also. It is KTG, that is kinetic theory of gases. So kinetic theory of gases of physics and states of matter of chemistry have been the concepts are same, and we deal with the same laws in chemistry as well as in physics also. Okay, so once if you study this chapter, it's a free hit for you in the physics, or if you study kinetic theory of gases from physics, it's a free hit for you in the chemistry. Okay, whatever, let's start with the gas laws. Here we have to study about the gas law, understand what gas law is, and from each gas law we will do a numerical problem relating to that particular concept. Okay, so first we are going to start about Boyle's law. So Boyle's law is a pressure volume relationship. Actually, what do you mean by Boyle's law, or what is Boyle's law? Boyle's law is a pressure volume relationship. That is the first point you have to understand. It's a pressure volume relationship. And what Boyle's law states is that the volume of a fixed mass of a gas is inversely proportional to its pressure at constant temperature. So this is the definition of that. Let me put it in simple words, that if you consider, see here it is, let's check the name here, it is Boyle's. We know that Boyle's, I am giving you a small thread to remember the relationship. That means boiling means to, you know that boiling of water. So boiling of water is related to temperature. Here the name of the scientist is Boyle. That means it is related to temperature. That means here temperature is constant. So that's how you have to remember. So if temperature is constant, then this law is connecting which two variables? It is connecting pressure and volume. Okay, so what is this law saying? If you are taking a fixed volume of gas, okay, fixed volume or fixed mass of gas, and what it says is that if you are applying the pressure, if you are applying pressure, let's see, this is a movable piston, it's a movable piston. If you apply the pressure over the gas, what happens? The movable piston moves down, that means the volume decreases. So if you apply pressure or if you increase pressure, volume of a gas decreases at constant temperature. This is what Boyle is telling. So we know that, right? Already we know this fact, because in a constant, if you are taking a gas of a fixed mass and if you are applying pressure over the gas, what happens is that as the piston moves down, the volume decreases as you keep on increasing the pressure. So pressure is inversely proportional to volume. This is the relation between pressure and volume at constant temperature, which is called as the Boyle's law. As you keep on increasing the pressure, the volume decreases. If you increase the pressure, volume decreases. That means the relationship between them is inversely proportional. So we can convert this proportionality into an equality. So while converting proportionality to equality, you can use a constant. So P equal to a constant K into 1 by V. That means we can say P into V equal to K, a constant. Okay, is that clear, students? So if PV is equal to a constant, what does that mean? You can read it here. It means that in a fixed amount of gas, at constant temperature T occupying volume V1 at pressure P1 undergoes expansion so that the volume becomes V2 and the pressure becomes P2, then according to Boyle's law, P1 V1 equal to P2 V2. What does that mean? Dear students, we have told that PV at constant temperature is equal to constant. PV at constant temperature is equal to a constant. What does that mean? It means that if pressure is changed, if you are changing the pressure, if pressure is changed, say if pressure is increased, then correspondingly the volume will be decreased in order to keep the value PV a constant. Okay. Say if I increase the pressure twice, that means let the pressure be 2 times, then what happens with the volume? Volume will decrease by 2 in order to maintain the PV constant. So that means P1 V1 will be equal to P2 V2. If the pressure is changed to P2, then volume will obviously change to V2 in order to make this product, that is PV, a constant. So that is what we have mentioned here. If a fixed amount of gas at constant temperature occupying a V1 volume at P1 pressure undergoes expansion, it can be a positive expansion or it can be a negative expansion with respect to the values of P1 and P2. If P2 is greater than P1, then it is negative expansion. That means it is compression. Volume will decrease. If the value of P2 is less than P1, that means the volume undergoes expansion or the gas undergoes expansion, and they expand or they compress in order to make the value PV a constant. So the total value of P1 V1 will always be equal to P2 V2. If we have another condition, that is the third condition, then obviously we can say that it will be equal to P3 V3. So this is what it means by PV equal to K. From this relation we can take this P2 to LHS and bring this V1 to RHS. We will get a new relation that P1 by P2 is equal to V2 by V1. Okay, that's the new relation. So dear students, please remember these two equations in order to solve the numerical problem from Boyle's law. So once you get a numerical problem, read that problem and understand what kind of problem it is. That is, if pressure and volume are the variables and temperature is the constant, then obviously that question is pointing to the Boyle's law, and we have to solve that problem using the formula we obtained from Boyle's law. Is that clear? Okay, now let's move on to the next slide. Okay, here there is a question. It's a very good question. See, a balloon is fixed with hydrogen at room temperature. It will burst if pressure exceeds 0.2 bar. If at 1 bar pressure the gas occupies 2.27 liter volume, up to what volume can the balloon be expanded? So what is the question all about? Here you can see that there is no change in temperature. They have mentioned that this process, whatever process we are talking about in the question, is taking place in room temperature. That means at constant temperature. Okay, now sorry for that. Now here you are filling a balloon with hydrogen gas. Okay, and they have told that it will burst if pressure exceeds 0.2 bar. That means there is a pressure 1, it is equal to 0.2 bar. So if you exceed the pressure above 0.2 bar, what do you say, the balloon will burst. Okay, now another pressure, that is P2 equal to 1 bar pressure. At 1 bar pressure the gas occupies 2.27 liters. So that is the volume of the gas occupied in the balloon, it is equal to 2.27 liters. So they are asking, if I am reducing the pressure, means the volume of the balloon increases. Okay, that means at what volume the balloon will burst. That means we have to find out V1. We have to find out V1. We got the point that it is taking, this process is taking place at room temperature. That means room temperature is a constant temperature. So it's a temperature constant process. Here they have told that at P2 pressure we got V2 volume. Then they have given that P1 pressure it is equal to 0.2 bar. Then what will be the volume at which the balloon will burst? So we have to find out what is the value of V1. So you can use the formula P1 V1 equal to P2 V2. So that V1 is equal to P2 V2 by P1. So that is equal to P2 is 1 bar, V2 is 2.27 divided by 0.2. That is equal to 2.27. 2.27, let's take it as 22.7 by 2. That will be equal to 11.35. So 11.35 liters is the maximum volume capacity of the balloon. As it reaches at 11.35 liters, the volume, the balloon will burst. So at 0.2 bar, it will be at 11.35 liter. If you decrease the pressure from 0.2, if you decrease the pressure from 0.2, what happens? What happens? The level, the volume again increases and the balloon will burst. Okay. So is that clear, students? So this is all about that question. Okay. Now let's moving on to the next law, that is the Charles law. So here also you might be thinking of any of the the trick to remember the relationship. You might have heard about the Prince Charles of UK. Prince Charles. So Prince stand for P. P means what? Pressure. So here what is constant? Pressure is constant. That means Charles law is related to volume and temperature. Charles law is related to volume and temperature. You know that as you increase the temperature, the water, the molecules absorbs the thermal energy and they starts to expand. So if you increase the temperature, the volume also increases. That means volume is directly proportional to temperature. As you increase volume, temperature also will get increased. So I can say that V equal to KT, that means V by T equal to a constant. So V by T equal to a constant, that means I can write it as V1 by T1 is equal to V2 by T2. That is, this is another important relation from Charles law. So that's an important relation from Charles law. So let's check another explanation of Charles law. You can see it here. The volume of a given mass of a gas increases or decreases by 1 by 273 of its volume at 0 degree Celsius for each degree rise or fall of temperature, provided pressure and mass is kept constant. What does that mean? See, if you are increasing the temperature, if you are increasing or decreasing the temperature, what happens? If you are increasing the temperature, that means temperature by 1 degree Celsius. Okay, by 1 degree Celsius. What happens? The volume will get increased. Okay, volume will get increased. How much it get increased? It get increased of 1 by 273 part of the total volume. This much of the total volume will get increased. So that's what I have written here in formula. The volume at T temperature is equal to initial volume plus T by, that is the temperature we have increased, T by 273.15 times initial volume. That is the total increase in volume as you increase the temperature. So this relation you have to by heart, this relation. Vt is equal to V naught, that is the initial volume, plus T by 273.15 into V naught. So this is and also this is a very important relation. You can study this also, and everything is from the same equation. We just reorder it. Here what I have done is I have taken V naught common outside. So 1 plus T by 273.15. You can, if you take the LCM, you get this relation as well. Okay. Now let's move on to the next slide, and this thing I have already discussed, that the volume of a given mass of gas at constant pressure is directly proportional to its temperature on the Kelvin scale, and that is V1 by T1 is equal to V2 by T2. Okay. Yes. Now let's do a problem. See, a gas at 300 Kelvin is compressed to reduce its volume to half of its volume. At what temperature will it become double of its initial volume? See, in this question they haven't said anything about pressure. So in such cases you have to consider pressure as constant. So here it's pressure constant, so there is a relation between volume and temperature, and we know that volume is directly proportional to temperature, and we know that V1 by T1 is equal to V2 by T2. Now at T1 temperature, T1, let's take T1 equal to 300 Kelvin, the gas is compressed to reduce its volume to half of its volume. That means the volume has been reduced to let's take V1 equal to V by 2. Okay. At what temperature will it become double of its initial volume? So I have to find out the temperature T2 so that the volume will become double of the initial volume. So initial volume is V, so it will become 2V. So we have to find out T2. Okay. So sorry, initial volume is V by 2, right? So if initial volume is V by 2, then obviously V2 should be equal to double of it, means V, right? V by 2 into V by 2, that means it should be equal to V. So V1 by T1 is equal to V2 by T2. That is equal to V1, means V1 is equal to V by 2 divided by T1 is 300. That is equal to V2 is V, and we have to find out T2. So T2 is equal to V into 300 divided by V by 2. Okay. So V and V get cancelled. So there was a mistake. Please pardon. Okay. So yeah. So initially, wait a minute. What happened is that I just reversed the case. Let's read the question again. At a gas at 300 Kelvin is compressed to reduce its volume to half of its volume. Okay. That means we are taking V1 is equal to V at 300 Kelvin. That's what it is mentioned. Okay. And V2 means V2 is equal to half of its, that is V by 2 at T2 temperature. This is what it has meant, and I have taken it in the reverse order. Okay. Now let's apply it. V1 is equal to V and T1 is equal to 300. That is equal to V2 is what? V by 2, and T2 is what we have to find out. So T2 equal to V by 2 into 300 by V. So I can cancel V and V. So T2 equal to 300 by 2, that is 150 Kelvin is the right answer. 150 Kelvin is the right answer. Okay. Now moving on to the next concept or the next law, that is Gay-Lussac's law. So from Gay-Lussac's law, it is easy that we already have kept temperature constant from Boyle's law and pressure constant from Charles' law. So obviously from Gay-Lussac's law, it will be a volume constant relation. It's a volume constant relation. So if volume is constant, then the relationship is between pressure and temperature. It will be between pressure and temperature. As you increases the pressure, the temperature of the gas increases. That means pressure is directly proportional to temperature, and pressure is equal to K, constant K into T, that is P by T equal to a constant. So P by T equal to a constant means P1 by T1 is equal to P2 by T2. This is all about Gay-Lussac's law. So let's read the statement here. It states that the pressure of a given mass of gas is directly proportional to the Kelvin temperature at constant volume. So here the volume is constant. So what it states is that the pressure of a given mass of gas, it is directly proportional to the temperature. This is what we have written here. P directly proportional to temperature. So P is equal to KT. P by T is equal to constant. So we can write P1 by T1 is equal to P2 by T2. Right? P1 by T1 is equal to P2 by T2. Okay. Now let's do a problem. A cylinder containing cooking gas can withstand a pressure of 15 atm. The pressure gauge of cylinder indicates 12 atm at 27 degrees Celsius. Due to a sudden fire in the building, the temperature starts rising. At what temperature will the cylinder explode? So you have to find out the T2 value at which the cylinder will get exploded. Okay, so let's write down the values that is given in the question. So we are given with P1 is equal to 15 atm, and we know that P2 is given as 12 atm, and the temperature T1 is 27 degrees Celsius. Dear students, you have to solve the problems always taking in the temperature in Kelvin. That is, for 27 degrees Celsius means 300 Kelvin is the temperature. Okay, how I got 300 Kelvin? 27 degrees Celsius is equal to, you have to change it into Kelvin scale. So in Kelvin scale it is equal to 273 plus degrees Celsius temperature, that is 273 plus 27, that is equal to 300 Kelvin. Okay, so what you have to find out? You have to find out the T2 temperature. Okay, so P1 by T1 is equal to P2 by T2. So what is P1? P1 is 15, T1 is 300, equal to P2 is 12, and T2 is what you have to find out. Here I can cancel this with 15 one time, here it will be 20. So T2 will be equal to 20 into 12, that is equal to 360 Kelvin, right? 360, sorry, 12 into 20 is, 12 into 2, that is 24, 240, right? It is 240 Kelvin. Kelvin. Is it? The pressure correspond. Oh, it is T1. Oh, sorry. Again, I made a mistake here. That is, in the question, it has been clearly mentioned that at 12 atmosphere, this pressure is at 27 degrees Celsius. So, correspondingly, I have to find out that pressure corresponds to 15 atm. Again, made a mistake. Please bear with me. That is, let's remove this. T1 is what we have to find out. T2 is what given, that is 300. So let me do it again. So these are the some mistakes we normally does. Always read the question carefully. So 15 by T1 is equal to 12 by T2, that is 300. So T1 is equal to 15 into 300 divided by 12. So you can cancel this with 3, 5 and 3 4 times. And you can again cancel this 150 and here it will be 2, again cancel it 75. So 75 into 5, what will be the value? 75 into 5, 25, 35, 37, 375 Kelvin. So T1 will be equal to 375 Kelvin. Okay, right. Now let's moving on to the next formula, that is combined gas law equation. See students, we have already studied three gas laws. If you combine all the three gas laws, you will get the relation as P1 V1 by T1 equal to P2 V2 by T2. So the combined gas law equation can also be used in numericals, where all the three are variables. When pressure is varying, volume is varying, temperature is varying, if all these three are varying, then obviously you can use P1 V1 by T1 equal to P2 V2 by T2. Okay. Now let's try one problem. A sample of nitrogen occupies a volume of 320 centimeter, it's centimeter cube, 320 centimeter cube at STP. Calculate its volume at 546.3 Kelvin and 0.5 bar pressure. 0.5 bar pressure. So here V1 is given as 320 centimeter cube. We have to find out the volume at 546.3 Kelvin, that is we have to find out V2. So for V2 we have temperature T2 is 546.3 Kelvin. And correspondingly the pressure here is P2 is equal to 0.5 bar. Initially it has told that V1 is 320 centimeter cube at STP. We know that at STP the temperature is equal to 273.15 Kelvin. So you have to understand that at STP means standard temperature pressure. At standard temperature pressure the temperature is 273.15 Kelvin. And what is pressure? Pressure will be equal to 1 bar. So that is what you have to understand from this. Okay. Now directly applying the combined gas law equation, P1 V1 by T1 equal to P2 V2 by T2. Let's apply it. P1 is 1 bar into V1 is 320 centimeter cube divided by T1. T1 is 273.15. That is equal to P2 is 0.5. V2 is what we have to find out, and T2 is 546.3 Kelvin. So here you can cancel this. 273.15 into 2 is 546.3, and V2 is equal to 320 into 2 divided by 0.5. Okay, that is 1.5 can be written as 1 by 2. So it becomes 320 into 4 equal to 0812. So 1280 centimeter cube is the answer. 1280 centimeter cube is the answer. Okay. Now the next law is Avogadro's law. So in Avogadro's law, it's the relation between volume and the amount or the number of moles. Okay. What this Avogadro says is that it states that equal volumes of all gases under similar conditions of temperature and pressure containing equal number of molecules. So this is very interesting fact. Let's explain this. I am taking two rooms. Okay, and that two rooms of same volume, identical rooms with same volume, temperature and pressure conditions. Here also same volume, temperature and pressure conditions. Okay, and I am filling this room with carbon dioxide and I am filling this room with oxygen. What Avogadro's law states is that if volume, temperature and pressure is constant, then the volume is directly proportional to the number of moles irrespective of which gas you have filled. That means if I say that if I am filling, or say that if this room contains 2 liter volume, say it consists of 2 liter volume, and this room also is 2 liter volume, and in this temperature and pressure conditions this carbon dioxide occupies or contains 100 molecules, say 100 molecules. Okay, without measuring the number of moles of O2, I can blindly say this room also will contain 100 molecules of oxygen. How? That is what Avogadro says. If volume, temperature and pressure is constant, then if you know the volume of a particular gas and you know that the other gas or the different gases is present in the same condition, then knowing the number of molecules or number of moles of a particular gas, that will be equal to the number of molecules or moles of the other gas which is in the same volume, temperature and pressure condition. Okay, that means volume is directly proportional to number of moles. If you increases the number of moles, the volume of the gas also increases, and we can write this relation that volume is equal to K into N. That is changing the proportionality constant into equality, you have to use the constant. So volume is equal to constant into N, where number of moles is equal to mass by molar mass, that we have studied from the mole concept. That is, number of moles is equal to mass by molar mass. If I take this volume over here, I get it as molar mass is equal to K into mass by volume, and mass by volume is what? Mass by volume is density. And these relations, dear students, you have to by heart all these relations, because you will be asked with different values. So if you know all these relations, then you can easily apply these relations or these equations and you can find out the value. Okay, now we are coming into the ideal gas equation. Dear students, what do you mean by ideal gas? Ideal gas are those gases which strictly follow Boyle's law, Charles' law and Avogadro's law. So those gases which strictly follow Boyle's law, Charles' law and Avogadro's law are called as ideal gases. So there is combining all the laws, even including Avogadro's law, we get the ideal gas equation, and that equation is PV is equal to nRT. Okay, so PV is equal to nRT is the ideal gas equation, where P stands for the pressure, V stands for volume, N stands for number of moles, R stands for ideal gas constant and T stands for temperature. We know that for R there are different values, that is 0.0821 or 0.083, 0.0821 liter atmosphere per mole Kelvin, or we have R is equal to 8.314 joules per mole Kelvin, or we have R is equal to 2 calorie per mole Kelvin. See students, if you are solving a problem, you can use the value 1 by 12 instead of putting 0.0821. This is a very important point that I want to share. See, instead of using 0.0821, you can use the value, the fraction 1 by 12, which is equivalent to 0.0821. So your calculation will become much easier and much smoother. And similarly for 8.314, you can use the value 25 by 3 instead of using 8.314. Okay, instead of using 8.314, you can use the value 25 by 3. Right? Now, the last topic that we are going to discuss today is Graham's law of diffusion or effusion. First, students, what do you mean by diffusion? See, if in a container, it is connected with a tube with another container. Okay, and this contains some gas, say oxygen gas, and here I have closed this container with a stopper, and here also there is gas, and that is, let's say, nitrogen gas. If I remove the stopper, the gas will get mixed up, and that mixing of gas is called as diffusion or effusion. Okay, the mixing of gas or the speed with which they intermixes, that is called as diffusion or effusion. So under similar conditions of temperature and pressure, the rate of diffusion of gas are inversely proportional to the square root of their density. You know that density means it is directly proportional to the mass. As you know that if the mass of the molecule increases, if you take the example of human, if a person with a fatty person and a slim person, who can run faster? Obviously the slim one will run faster, and the fat one, the obese one, cannot run that much faster because of his mass. Okay, so similarly the gas with lesser molecular mass have a greater rate of effusion or diffusion. They can mix so fastly because they can move so smoothly. If the molecular mass increases, as the molecular mass increases, the rate of diffusion or effusion decreases. The rate decreases. The rate means the speed with which they intermix. Rate means the speed of the molecules. So speed of the molecules is connected to the density or the molecular mass. If molecular mass increases, the speed decreases. So R is inversely proportional to the square root of density. So this is the relation you have to study. R1 by R2 is equal to root of D2 by D1, or it is equal to M2 by M1. Okay, it can be R1 by R2 is equal to root of D2 by D1, or it is equal to M2 by M1. So this equation or this relation is also very, very important, because you can expect direct questions from this point. Okay, you can expect direct questions from these segments. So dear students, this is all about the laws that you study in states of matter. We have covered all the laws that is present in states of matter, and we also have done certain numericals with regards to those laws. Hope this class is helpful for you. Hope every concept is clear for you. If you have any doubt, feel free to ask in the comment section so that I can clear all your doubts. Okay students, so let's wind this session. So that's all for today. Thank you. Have a nice day and have a good sleep. Okay, so thank you students.